Okay, I think we're ready to go. So, hello everyone. On behalf of the Vulkan Working Group and Kronos and the whole Vulkan ecosystem, welcome to the Vulkan BOF at SIGGRAPH. I'm Tom Olson. I work for ARM, and I'm chair of the Vulkan Working Group. So over the next 3 hours, we have 5 exciting presentations and mine. I won't introduce them now, but I'll refer to them during my presentation, which comes first. Please note, we're very short on time. There is one 10-minute break. Use it wisely. And please do get back in time for so that you're not straggling in while Hai is talking when he starts, because he starts immediately after the break. We do not have Q&A on the agenda, I don't think. Am I wrong? Lisi's not here. Q&A, well, we have a party afterwards. You can come to the party, and I will be there all night, I promise. But yeah, we'll do what we can. It's informal, it's a BOF, and we're all friends here. So I've already introduced myself. My talk is the first talk, and it is sort of a working group chair's perspective on Vulkan's past, present, and future. I'm going to cover what's new in the API, also what we're working on in the future, and finish with what's new in the Vulkan ecosystem. So for the record, Vulkan 1.0 was released 8 years ago, but it was kind of a shock to me to realize when I started putting this talk together that it was actually 10 years ago at the OpenGL BOF at SIGGRAPH that we told the world that we were going to do something new and started the journey that we're still on. So I wanted to start this talk by acknowledging that history, that milestone, look back a little bit at where we started and what we learned along the way. So our starting point, because of where we were at the time, was a list of the problems with OpenGL. The community was not happy. We were not satisfied. We had problems to solve. Some of them were just age. Some of them were fundamentally down to the fact that the programming model of OpenGL did not reflect very well what the hardware was actually doing. So we did a sign flip on all those problems and came up with a list of goals, and that was what we were going to try to do. These slides all come from that original presentation 10 years ago. In the interest of time, I won't go through the goals. Over the ensuing 18 months, we worked extremely hard. During that time, the API got renamed to Vulkan instead of Next Generation OpenGL. I would argue that we nailed many of the goals. Some of the others, your mileage may vary, but we at least made progress, I think, on all of them. And at the end, February 2016, we released Vulkan 1.0. And then the fun really started because you all started trying to use it. And we had thought we were ready. We had done a lot of work to get ready. We were not as ready as would have been desirable. So we learned a lot of lessons, especially at the beginning, but we're still learning today. Lesson 1, open source. Whoops, what happened? Yeah, okay, good slide. Open source is amazing. We planned from the beginning that we would release conformance test and tooling in open source. We decided very late, close to release, that we were also going to open source the spec. And I thought it was a bad idea. And I was so wrong. It was one of the best moves we ever made. The feedback, the value that we've gotten from community input on the spec has been just incredible. So now I cannot imagine operating any other way. Lesson 2, you can do too much testing, maybe, but if you don't think you're doing too much testing, you're not doing enough. And we learned this lesson the hard way. Early implementations of Vulkan were pretty crappy, and it took us a good while to get that bad taste out of people's mouths. Conformance testing today is our #1 expense. We spend more than $500,000 a year on it. We have a team of 5 working 4.5 working full-time on improving conformance, currently at about 2.5 million test cases. Lesson 3, It takes an ecosystem to raise an API. A spec by itself does nothing. And back in the OpenGL days, we did the spec and we sort of assumed the rest would take care of itself. It did not. So we think about things differently today. We recognize that we can't do all of this ourselves, but we also recognize that if anything in the ecosystem is broken, it hurts us all. So in some sense, we don't have the authority, but we have the responsibility to make sure the ecosystem works. Whoops, I think I lost a slide. I did. Lesson 4, I guess, is you can't just let evolution happen. In nature you can, but you have billions of years. We don't have billions of years. So we believe that Vulkan's evolution has to be planned. So I'm going to go super meta on you right now and explain the way Vulkan evolves has evolved. Did you get that? So I have to apologize if it's a bit dry. I am a professional standards committee chair, so I really get off on this kind of thing. I'll try to go through it quickly for those of you who don't care quite that much. The reason I'm telling you is that if you know how it works, you can influence its direction, and I very much want to empower you to do that. So in the past, I was guilty of showing slides like this. I claimed at the time that, you know, nice linear sequence of versions, and you add some more features, do another version, lather, rinse, repeat. That was kind of true for 1.0. It was a little bit true for 1.1, and it hasn't been remotely true since. But now I'm telling the truth. This is what really happens. After 1.0, we started writing extensions. These little arrows are extensions, little points in time. Some of them are tiny, point features and bug fixes. There's medium-sized features, and sometimes you get transformative stuff, descriptor indexing, or ray tracing, that just changes everything. And then every once in a while, when it was time to make a new version, we would cherry pick some of those extensions that people seemed to like and that seemed to work well and everybody could support, and we would promote those into a new core version and take all the suffixes off and change the names, which was super annoying, but that's how we used to operate. This kind of worked, but there was a problem with it. We want Vulkan to run on a very wide range of devices, from very high end to very low end. And when I say low end, I don't mean cheap cell phones. I mean Coke machines, right? And those are not very capable devices. They're very cost sensitive. So what that meant was, when we pulled these features into a new core version, we couldn't make them mandatory because they wouldn't run on a Coke machine GPU. What we had to do was make them optional. There were quite a few optional features in 1.0 and 1.1. In 1.2, like 3/4 of the features were optional, and everyone hated that. And we knew it was a bad idea. We didn't know what else to do at the time. But we figured it out. So starting with 1.3, first of all, we said everything new that goes into 1.3 is going to be mandatory. There were some nice things, actually, dynamic rendering, buffer device address, fairly advanced features. But still, it was a limited subset of what we thought the ecosystem really needed. So in addition to 1.3, we released something called the Roadmap 2022 profile. So a profile is a core version plus additional required features, required extensions, increases in limits, et cetera. And for us, the roadmap profiles represent the features you can expect to see in mid to high-end devices, not Coke machines, starting in 2022. Probably desktop at the beginning of 2022 and mobile kind of at the end and staggering into 2023, but ballpark. And our commitment is that all of the GPU vendors in Kronos agree that this feature set is the future, and we will all support it in a relatively near time frame. So this past January, we released an update, Roadmap 2024 profile. That's the feature set moved forward 2 years, and we expect to continue that cadence going forward. There's one more piece to the puzzle. I said we wanted to have a planned and coherent roadmap going forward. So, in addition to roadmap profiles, we have what we call roadmap milestones. Think of those as buckets that hold technology or problems that we want to solve. And they're associated with times, and the time we put a particular feature into is a time when we think developers are going to need it, and all of the mid to high-end GPU vendors will be able to ship it. So that's how we're going to try to structure things going forward. Then what we do is we use what's in the buckets to guide what extensions we work on, to prioritize them. So to recap, roadmap milestones guide what extensions we write. Extensions get rolled up into roadmap profiles at the appropriate time. And then, in case you're wondering, we do it at times when the time is right. We also write core versions. And we will, in fact, probably release a Vulkan 1.4 at some point next year. However, I hope I've convinced you, unless you're in the Coke machine business, the core version is not exciting. Pay attention to the roadmap profiles, because that's where the action is for serious, cutting-edge applications. So, sorry if that was dry. I am done with Meta now. Next, I'm going to talk about what we've done in the past year, particularly Roadmap 2024 profile. And after that, I'll talk about what's in some of those buckets at the top right. So, big thing we released this year is the Roadmap 2024 profile. Came out in January. It's our best guess at what will be becoming standard in the mid to high-end products starting this year. So first thing you get in it, obviously, Vulkan 1.3 plus the previous roadmap milestone, which actually had some nice stuff. Descriptor indexing, real subgroups, that is, subgroups larger than size 1, and useful drawing features. There's a bunch of features that were optional in 1.0 and 1.1 that are now mandatory. My favorite is, subword data types in shaders, but pick your favorite. Implementation minima, you're now guaranteed to be able to bind up to seven descriptor sets, and to build frame buffers with up to 8 color attachments. And then there's a stack of extensions that have been released over the years that are also now required to be supported by devices that support this profile. I should say, because it's a profile, these are still extensions and you still have to enable them to use them. The thing about the profile is that if the profile is supported, you know they are supported. You know that the extension is there. There's a couple of new extensions that we threw in as well. I don't have time to talk about most of them. Shader float controls is the one that interests me most. It gives you the same degree of control over floating point behavior that you have with OpenCL. There's a pair of awesome extensions, and the best thing about them is if they're there, turn them on and forget about them. You don't have to know. What they do basically is make subgroups and texture LOD computation for sampling work the way you thought it did. It actually doesn't if you read the spec very closely, but with these extensions it does, so you want them. And for an explanation of that, by the way, there's a wonderful blog by Alan Baker of Google on the Cronus website that explains why they were necessary and what they do. Because we are very short on time, I think I will skip talking about dynamic rendering local read in detail. The key thing from my perspective as a guy in the mobile industry is that if you have this, which is in the roadmap, and you also have rasterization order attachment access, which is not in the roadmap. It's probably not going to be supported on desktop immediate mode renderers. You have the functionality of frame buffer fetch, and you can use it in dynamic rendering, which means that if you no longer have to fall back to using subpass dependencies and render pass objects, if you want to take advantage of the magic that tilers can do with accessing, having one fragment access data left by a previous fragment. And there are blog posts, again, on the Cronus website that talk about how these work. There's other stuff that we've released in the past year. Not going to talk about it. Just didn't want you to think we'd been sitting on our hands. I will mention video. The cool thing in video is that the encode stack is now final. The specifications are released and official. We also have decode for AV1, which has been eagerly anticipated in the community. And there's a couple of blogs. I didn't put URLs because they're annoying, but if you go to the Cronus website, look for blogs, you'll find descriptions of them. So that was where what we worked on and have released this past year. I want to talk now about the future. This is something we have historically avoided doing for reasons. But again, I said we want to empower you to influence the roadmap, and you can't do that if you don't know what it is. So with that, I'll take a deep breath and take a risk. Starting with the obligatory disclaimer, we are talking about the future. This is what the working group plans to do, and we've spent a lot of time making the list. But if you've been in the industry for more than a week, you know things happen, stuff changes, priorities change. So I am very sure that we're going to do quite a bit of the stuff I'm about to tell you about. I'm also pretty sure we're not going to do all of it. And if the future ends up being different from what I'm about to describe, please don't, Okay, so Roadmap 2026 milestone. This is a milestone, not a profile. The reason it's a milestone is because we can't write a profile when the extensions haven't been written yet. So this is work that's in flight and still under negotiation. What's in the milestone bucket is a list of capabilities we want to provide, pardon me, or problems we want to solve in that time frame. And for the sake of helping us think coherently, the items are grouped into themes, which I will now go over a little bit. So one of the milestone themes is robustness. By 2026, web GPU is going to be everywhere. We're quite sure of that. And people are going to want it to run fast. Robustness, by improving Vulkan's robustness guarantees, web GPU implementations can do less runtime checking, and they will run faster, and that will be good. We also want to support the Rust community, who are very interested in, it's kind of their thing, is being safe and robust. The work items in the bucket, Robustness 2 is already published. You can use it today, but many of the features are optional. In the roadmap, when it becomes a roadmap item, we hope to make those features all mandatory. We are looking at range-checked pointers, Google Cherie, if you want to know what that looks like. And we have an extension coming out very soon called Pipeline Binary. Has a number of interesting features. The reason that it is relevant to robustness is that the Chrome Web GPU team is going to use it to help them make their Web GPU implementation tolerate feeding bad SPIR-V to a compiler and having it crash, which sadly some of our compilers still do. Another theme, unified compute. This basically means we want Vulkan to be as good a target for high-performance computing or serious computing in general as OpenCL is today. Most of the things we need are around how you allocate and access memory. Vulkan, is all about buffer objects and image objects and all these objects. And for a computing API like OpenCL, you kind of just want to talk about memory. And there's various things that we have to do to make that work. So the list includes untyped pointers, so you can do typecasting or pointer casting, 64-bit addresses, shader, and then you need to be able to do 64-bit arithmetic to play with addresses. So those things are all on the list. State management is a long-standing problem for developers, and we are continuing to work on that. The shader object extension you may be aware of, currently supported, as far as I know, only on NVIDIA GPUs. It's a really nice model. it's quite difficult to support. So we would like to do something like that, but we probably have to change it. So that's on the drawing board. We also have an extension to try to make it sort of less expensive to support dynamic state in implementations. And there's a very nice API on the drawing board for simpler descriptor management. Machine learning, why would anybody want that? That was a joke. Yeah, because machine learning. So cooperative matrix, we already have a version. There's a version 2 on the drawing board. NVIDIA has this proposal for something called cooperative vector, which lets you dispatch small multi-layer perceptrons from inside, for example, a fragment shader. And I actually heard that mentioned in the first Advances in Real-Time Rendering talk yesterday. So the community is definitely looking forward to this. So we are too, we're working on that. And then there's small technical stuff like bfloat types, etc. Debugging, the device fault extension is shipping and starting to show up in implementations. We want to extend that with other tools that will help you debug. And Jeremy will be talking about debugging further because we already have some stuff coming, or rather he does. There's other stuff. The only one that I'll mention, fragment shading rate, otherwise known as variable rate shading. We believe we will all be able to support this in 2026, so it's on the roadmap. 2028, our crystal ball is necessarily fuzzier. Perhaps this may surprise you, but we expect that everybody, including the mid and upper mobile, will be supporting all of the ray tracing features that are in the API today in that time frame. So that's pretty cool. GPU-driven rendering, we are obviously very interested in various kinds of GPU-side dispatch. We've talked about a number of them. Work graphs is a candidate, and we're interested in that. It's also tricky to support. We'll do something like it. If we don't do that, we will do something like it. And then there's some additional robustness features. Other things that we worked on, that we are working on, that are not in the roadmap, but that are currently in flight, ray reordering extension for ray tracing, videos working on AV1 encode, and also more sophisticated encode tools. And VP9 is, I think, not actively worked on yet, but it's in plan. And then machine learning is also working. We have separate subgroups that deal with each of these topics, and they each meet weekly or every other week. Last, what we're working on, topic shading language management. Vulkan, as you know, accepts SPIR-V shaders. In theory, how you generate SPIR-V is up to you. In practice, so in theory, we don't care, but in practice, we do because, like I said, it takes an ecosystem, and we have to make sure the ecosystem works. There are 2 languages in current common use, GLSL, obviously, and HLSL. Neither of those is going away, and we're doing our best to support both of them. They each have their niche. They kind of non-overlapping almost. I do want to give a shout out to Microsoft. They've been very supportive of our attempts to make HLSL generation, SPIR-V generation from HLSL for Vulkan work well. We appreciate that. Of course, they can't do our work for us, and it's expensive work, so we're having some trouble resourcing it. A new option that came up recently, NVIDIA has a cool language, started as R&D, but it's pretty industrial strength now, called Slang, which starts with HLSL and then adds a whole bunch of really cool and interesting features. They are trying to make it more available, and as part of that, they are sort of trying to not have it be seen as and not be controlled by them. They are looking to put it under the control of the community, which is fantastic, and we thank them very much for that. One obvious way to do that would be for Cronus to take over management. So we are discussing that now actively internally. It is, we haven't decided to do it. We're talking about how would it work, and would it be indeed good for Slang, good for Vulkan, good for the whole ecosystem. And do I have? Yes, I do. Immediately after the break, Hai Nguyen of NVIDIA will talk about how that's going to work, or how slang works, and how you can generate, how you can use it with Vulkan. Okay, I'm realizing I have a time problem. I have not much time left and a lot to say, so I will edit heavily on the fly. One thing I wanted to say, obviously a ton of stuff going on in the API, and we are working hard, but we could really use your help. We need input, and you can give us input face-to-face at events like this or at Vulkanized or anywhere. It's even better, actually, if you open issues on the GitHub repository, Vulkan Docs, which is where the specification lives. We are friendly. If you raise an issue that's irrelevant or that needs to be redirected, we'll do it. But we still appreciate your input, and we will be grateful for it, and you will get an answer from us. If you can contribute to the rest of the ecosystem by writing code for some of the open source resources, repos, that would be great. And if your company has a financial interest in seeing this work go forward or influencing how it goes forward, consider joining Kronos. It's not free, but it is cheap. The fee you pay is cheap compared to the cost of the time you, as an engineer, will spend. To be effective, to influence the working group effectively, you're probably spending at least 10 to 20% of your time. You guys who work there think that's fair? Yeah, that's about right. And you can spend more. I'm full-time. So as I say, the cost of having you work on it dwarfs the cost of joining the organization. So I wouldn't worry about that. If you work for a small company, ISV, something like that, we do have a sliding scale special class of membership called Associate for small companies, and we have academic memberships. Okay, Vulkan ecosystem. I'm not going to talk about the SDK because Karen's going to do that. And Jeremy's going to talk about the crash diagnostic layer, which is the latest cool feature. 3 weeks old, 2 weeks old in the SDK. 1 week, okay. Vulkan video is a thing. This is really cool. So Vulkan video is officially supported in mainline FFmpeg 7.0. It's supported in stable releases of GStreamer, and that means that applications like MPV that use it are, you kind of get it for free. You may have to tweak a setting. I'm not sure about that. Ray tracing is arriving in mobile now. It's not news on the desktop, but it's kind of a new thing in mobile. ARM and Qualcomm have demonstrated hardware-accelerated implementations. Samsung has a hardware-accelerated implementation, and content that uses ray tracing is shipping on some of Samsung's Galaxy phones. As far as applications, games are a given, right? How many game pictures have I showed over the years? The other thing I'm pretty excited about is the rise of using Vulkan in professional rendering applications. It's used in various Adobe applications like Substance 3D. Autodesk has started using it years ago in Fusion 360, and they're just doing all kinds of amazing stuff with it now. And in fact, the grand finale of today's BOF will be a presentation from Henrik Ashwin from Autodesk. Henrik and Ashwin from Autodesk, Caroline from Pixar will talk about how they're leveraging Vulkan in the Storm renderer. I am, in the interest of time, because I'm over time, going to skip talking about documentation and samples. They exist. And Vulkanized exists. It's an awesome 3-day conference, tons of fun. And the call for papers for Vulkanized 2025 is out. So just Google Vulkanized 2025, consider whether there's something you want to share with the community. There's one more thing I have to say. 10 years, wow. It has been 10 years. I have practically worn out this coffee cup, chairing meeting after meeting after meeting and phone calls, et cetera. I have decided that for me, it's time to step down. So Next year, when you come back, somebody else will give this presentation. We're about to run an election, and there are several extremely qualified candidates, so I am completely happy that Vulkan is going to be in good hands. Working on Vulkan has been incredibly rewarding for me, the most fun I've had in my career, and I am very proud of what we've achieved. I'm incredibly excited to see what happens next. So I'd like to thank the working group. It's an old picture, but most of these people are still there. Sorry? That was 2017, Vulkan 1.1. But as I said, most of those people are still there. I would like to thank them for making this possible, because I couldn't have done any of this by myself. And I would like to thank the user community also because it takes an ecosystem, and we have worked together to make this happen, and will continue, I'm sure. So thank you for driving us, the working group, to make Vulkan ever better. So I'm done, and I have put us only 1 minute behind. Karen, you're up.